Hey everyone, welcome to part 4. In this video, we will be building an end-to-end AIOps project. And this is where we will be adding AI into our DevOps workflows. So far, we have built an end-to-end project, deployed an e-commerce application locally, provisioned a whole infrastructure on AWS, ran CI/CD pipeline using GitHub Actions, configured Argo CD operator to sync with Git Repo, and also configured the observability layer using Prometheus and Grafana. Now we are adding intelligence to it. In this part, you will see how AI can actually assist in operations. By the end of this video, you will have an AIOps assistant to troubleshoot production issues for you. You ask a question, it fetches the data, reasons through it, and gives you a root cause. And if you haven't watched the earlier part, I'd highly recommend you to do so. In part 1, we covered the main system design concepts you must know that will also make you interview ready. Part 2 covers all the major DevOps workflows you must know. Part 3 is the full project implementation using those workflows. And we have used Cloud Code there. And this is the one where we take it further with AI. Now, if you haven't implemented the project yet, that's okay. This video will give you a mind map of how AIOps actually work. So post this video, you can go back and deploy the project, and then you can further enhance it with this AIOps agent. Let's get into it. Now, in this part, we are going through some concepts that are different from the traditional ones. Number 1 is foundational model. It is a large pre-trained AI model that you can use as is without training the model yourself. So we are just leveraging a model, not training it. Second, model as an API. In part 1, we went through the whole API design concept. And here we are actually applying it for ML workloads. So instead of hosting the model yourself, you call it over HTTP like you can call any other service, and you will get a response back. Third, inference. When a model takes an input and generates an output, it's just like a box. Your job is to give an input and you get a response back. Next is prompt engineering, and this is very important. The way you frame your question changes the quality of the answer the model produces. So how you talk to AI matters a lot here. Then there is system prompt. This is basically the instructions you give to the model before your conversation starts. This is where you define its persona, what it will act like, the boundaries, what questions it should block, and the overall behavior. In our AIOps assistant, we give it a role to diagnose production issues, for instance. The next concept is agent. I know you have heard the buzzword a lot, but there's a difference between an agent and an LLM model. Agent is a model that just doesn't respond. It acts. It decides what tools to call, in what order, to complete a task autonomously. Next is tool calling. The model can invoke external functions mid-reasoning. The model decides what to call, when to call, and what to do with the result. Then we have context window. This is the memory the model has within a single conversation. Everything, your question, the logs fetched, the previous metrics collected, everything has to fit under this window. Then another concept we'll touch upon is serverless, where you write a function or a process you want to execute and the cloud takes care of the server. So you are not provisioning anything here. You're just focusing on the function. And the best part about serverless is you pay only per execution. So it's very cost effective. In our case, we will be using AWS Lambda and it will be integrated with our agent. Next, we have event-driven architecture. This is one of the key system design concept which you should be very familiar with. The essence of event-driven architecture is nothing runs until something happens. In our case, a user question will trigger the agent and then the agent will trigger the Lambda function. So you see every process is dependent on an event. Now, next we will be going through a few cloud services that you may or may not have worked before. First is AWS Bedrock. Think of Bedrock as AWS managed AI platform. So instead of provisioning your own GPU clusters and hosting your model, Bedrock gives you access to foundational models such as Claude, Llama, Qwen, Mistral, all through a simple API. No infrastructure to manage, no model weights to download. You just pick a model and call it. Second is AWS Bedrock Agent. So the Bedrock Agent is a feature on top of Bedrock. Like I said in our previous concept, having a model is one thing, but an agent takes it further. It adds the reasoning layer. Think of it like a senior engineer in your team. You don't tell them what to do step by step. You give them a problem that we are seeing 503 errors in our production logs, and it will figure out itself. We'll go fetch the logs, run its analysis, and come back to you with an answer. Third service that we'll be using here is AWS Lambda. If the agent is the brain, as we discussed before, Lambda is a serverless function and it's playing an important role in our project. So the agent is the brain. But a brain with no hands cannot do anything. So the Lambda function here are the hands. Each Lambda function that we have implemented has a specific capability that the agent can reach for. Need logs, call Lambda function 1. Need metrics, call Lambda function 2. Need to check if our EKS pods are crashing, call Lambda 3. In Bedrock's world, these are called action groups. Basically, the skills the agent has access to. And these Lambda functions are basically talking to AWS APIs that you already have. So no new infrastructure. You're only putting an AI reasoning layer on top of what already exists. Fourth cloud service that we are also using in this video is AWS CloudWatch. In part 3, we already implemented Prometheus and Grafana for metrics collection and visualization. Here, we will be pushing logs from our application to AWS CloudWatch. And if you're familiar with CloudWatch, what we used to do is go look into the logs in detail, query it, see what happened, what crashed in our application. In this project, the agent will query on your behalf. So your logs and metric don't change here. What changes here is who's asking the questions. It's not us, it's the agent that we will deploy. And the fifth service here is Streamlit. This is basically our front end. It's a Python UI framework which is perfect for creating interactive web apps using Python scripts. So Streamlit will help us deploy the UI and we will be interacting with the agent through it. Before we go into deploying these things, let me give you a sneak peek of how it will actually look like. Here we will have this chat interface. We have named it as Kira, and in the chat box you will ask a question. Why are we seeing 503 errors? That request goes to the Bedrock agent running a model as the reasoning engine. It hits the agentic loop and decide, I need logs, I need metrics. Let me check the service health. Then it calls the 3 Lambda functions, and those functions then call CloudWatch. In that particular flow, the function fetches the data and hand it back to the agent. The agent reasons through it. If there's high error rate on the service, memory spike, any task that restarts or correlates to the 503 window, the agent will give you the root cause plus the remediation step. So basically in this chat app, there would be questions in and diagnosis out. So let me walk you through the architecture real quick. You have this UI chat interface, which I've named Kira. And what that agent does, it calls the AWS Bedrock agent on the backend. And this agent is what is doing all the work for us. It is powered by Qwen model. I've used Qwen specifically because it's cost effective here for our project, but you can also test different models. And there are steps if you want to use, for instance, Claude model. You have to submit a use case, and then once your account is assessed, you can start using it. So what we do next is we create an AWS Bedrock agent that is powered by 3 Lambda functions. And these Lambda functions do all the invocations for us. For instance, it can fetch logs for us. It can fetch metrics for us. It can go and check if our EKS cluster health is fine. So when you type something like, tell me which service is down. So what happens is this agent goes and triggers the model, and then the model makes some API calls, do the tool service calls. It gets the answer, it works on the response, and then gives it back to you. So this is the workflow we are implementing. So in the next few minutes, we'll be doing a bunch of things like setting up right permissions, making sure logs are exported to CloudWatch from which the agent would read and analyze. Make sure our Prometheus metrics are also exported so that the agent can read through it. Deploy 3 Lambda functions, which would be basically fetching logs, metrics, and send it to model. And once we deploy the Bedrock agent, then we will be deploying the Streamlit application to give that cool UI feels. Let's just start our Claude. So this is the project structure. This is the AIOps assistant. I have different functions here. So when you are building it, make sure you see these 3 functions. I'm going to just make sure that it's here. So if you can see it on full screen. So yeah, there are 3 functions. One is fetch health, another is fetch logs, and then third one is fetch metrics. We will be deploying it. We will be sending some invocations to see what the response is. So hang tight. After that, we also have a deploy script. I'll just open it here. So this is the script that will help us deploy the Bedrock agent, and we'll go through it in detail. So in our last part, we deployed the whole boutique application, which is here and it's up and running. We also deployed Argo CD operator, so we can see if any of the services are out of sync and how Argo CD operator can help with the drift. Next, we also set up Prometheus, so it's still scraping metrics from our pods, our services, our deployments. And then we can also visualize it through our Grafana dashboards. So until this part, in our observability side of house, we have metrics to see, okay, what CPU is high, if our servers are hitting any memory issues. So that part is covered by Prometheus. But how do you analyze if something is actually wrong? For that, we need logs. And in this project, we're using Fluent Bit. It's a standard log collector for Kubernetes. And what it helps us achieve here is that by default, Kubernetes writes all the pod logs to stand it out. When we deploy Fluent Bit, it runs as a daemon set in all the nodes. And what it does is it collects those logs and then export it to another platform. And this platform could be a managed observability platform, something like CloudWatch for AWS or Cloud Observability Suite in GCP. So in a nutshell, what FluentBit will help us do is get the logs and push it to CloudWatch so we can analyze further. One quick check that you have to do before we do anything, we have to make sure our node or our EKS cluster servers are able to write to CloudWatch. So before you start deploying, what you need to set up here is go to roles. Here you have to find the EKS cluster node role. Just make sure it's exactly the node role that's associated with your cluster nodes. And here I have added a CloudWatch agent server policy. I'll show you what the policy does. So if you see the access level, right, this node role has permissions to list, write to CloudWatch, which is basically what we want right now. We want all the logs that are coming from our pods to be written in some log streams, which is in CloudWatch. But I also want to make sure that this particular role has permissions to create new log groups, create new log streams, and describe those log streams. So I'll just create an inline policy here. I'll go to roles again here, and then I'm going to add permissions. And I'll create an inline policy in JSON. Here I'm going to add a policy. So it's closed. This is closed. 22. Okay, this is good enough. Will do. This is basically our Fluent Bit CloudWatch policy. Let's just create this. And now our role has permissions to create log streams, describe log streams, etc. So once this is set, now we can go ahead and install Fluent Bit. So in that case, what you have to run is Helm repo add. This is AWS, and then I'm going to add the link where the EKS charts are. Oops, I missed an H. Let me quickly fix that. This is where all our EKS charts are loaded. I'll just say yes and don't ask me again. So it's already there. So next I'm going to install FluentBit. After this, I didn't copy paste, so I'll just write it down. Helm repo update. Make sure all the latest repositories are updated. And then we are going to run this command, Helm repo. I'll show you in our text what it looks like. So here we are installing the AWS FluentBit repo, and it will create its own pods. So now I can come here and run this. FluentBit is running, and your logs of the cluster will now be forwarded to CloudWatch under this particular log group. So let me just go to CloudWatch real quick and show you if it's exporting the logs. And this is our EKS boutique. So you see all our log streams are getting generated from FluentBit. So all our pods are up and running. So our application is also up. So our first step is done. We are exporting logs from our EKS cluster nodes to CloudWatch, which will help us to analyze the events further when we are deploying the agent. So our log collection is set. Now the next step here is we need to deploy 3 action groups, which is basically 3 Lambda functions that our agent will call. And in order to do that, first we have to set some permissions. We'll create a Lambda based role. So we'll go to IAM. Here we'll go to roles. We'll just create a role, and the service here would be Lambda. That's our trusted service. Next, we'll just skip this for now. And here we will name it as AIOps Lambda role. And then we'll just create the role for now. Once it's done, open this. In the permissions, you can say create inline policies, and you'll select JSON. Copy this. I'll give you this. So what it's basically doing now is Lambda will have permissions to read your cluster resources, that's EKS resources. So by default, AWS works with zero trust policy. Every service has to authenticate with another service before it makes any calls, and the roles and permissions helps you do that. So here, these are the permissions we'll give to this Lambda role. We'll do next, and we'll put this policy name as AIOps read access. So you can see your CloudWatch list read, CloudWatch logs list read, and then even for eCase, you can fetch the resources. So now in this particular role, we have all the permissions set for this particular Lambda role. Now, our next step is to create Lambda functions. So we'll go to the Lambda service here. Before we go into creating functions, let me walk you through the 3 functions that we'll deploy. Like I said before, these 3 would be the action groups, basically the functions that will do the task, but an agent would be fetching information from these functions, analyze it, summarize it in a way that we have prompted it to, like we'll give some system prompts to our Bedrock agent, and then it will output the response in that format. So in this case, what we want to do is, so if you see this function, we're just fetching the health status of our eCase cluster. So we have given like the default params is goes and fetches eCase cluster resources. This is the particular namespace. We are also giving a Prometheus URL, but this is something we will have to first set up. So right now, if you go and see kubectl get service and monitoring, so if you can see this particular service, the type is cluster IP. So when you have the service type as cluster IP, it is only accessible within the internal cluster. Now, what if our agent wants to make a call and fetch the metrics of Prometheus? So we have to make it either load balancer type or ingress type, right? So that it's externally available. That's one of the service type, right? You have 3 by D. So you can, by default, Kubernetes creates a cluster IP, but you can patch it to make it load balancer. This is what we will be doing. So we are going to patch this service, control all, and we are making it load balancer. We'll wait until the IP, external IP is available. So see, Claude Code helped us. It's case sensitive, so it made sure that it's not failing or we're not getting any error out. This is where our service is patched. Now it's load balancer type, and we can quickly run this command and get the host name, because that is what we will be adding in a Lambda function. So if you see, this is our host name, and we go back to our Lambda function, and you see it's port 9090. So we will make sure it is correctly formatted. Okay. So now this is where our Prometheus is exposing the metrics. So if you do /9090 to this URL, you can fetch all the real-time metrics. So once we have changed the Prometheus URL, we can go through like what this function does. Now going to the second function, which is the fetch health function. So this function is designed to give complete health check of your eCase cluster. So we go into our Lambda handler first, which is again the entry point. Here we give the cluster name and the namespace. It basically maps the overall health. This function is doing that work. So through this function, we are also running some Prometheus queries. For instance, in this section, if you see, we are comparing desired versus available replicas for every deployment. So it can detect if anything is underscaled or failing. It's again in this case, we are querying Prometheus to make sure if there are any pods that are crashing or there are any restarts. Finally, it aggregates it in the return response. You can see it aggregates everything, the cluster status, node health, deployment, any pod issues, and it forms a structured JSON response. So giving like basically the health flag to the UI and the agent. Now let's go into our third function, which is our logs function. This particular agent group will fetch the logs. The goal of this function is to fetch and filter logs from CloudWatch for debugging purposes. So let's go to the Lambda handler again. So here we are passing input patterns like errors along with like the log group name and the time range. Then it uses the Boto3 client again to make the calls to the CloudWatch logs and search through logs within this time window that we have passed. Once that's done, it filters out the relevant log events based on the patterns and the limits, just to make sure that it's giving us the concise format. If there are no logs, it will give you a no logs found message. But if in case there are logs found, it's going to format it again into the JSON format. So these are our 3 functions that we'll be deploying. So let's go to our Lambda console. and then let's start deploying. Let's deploy AIOps. It's already written here. We'll use Python 3.14. Here we'll keep it as it is. Let's change this. We'll use another role here, and this would be our AIOps Lambda role. We'll create this function. We'll ignore for now. And then we will go and fetch our Lambda function. This is we'll copy this. We'll paste it here. All looks good. No indentation error. So this is our function here. We have our Lambda handler. We are importing all the libraries. Everything looks good. And we will go ahead and deploy this. This looks like it's updated. We'll just close this. Now maybe we'll do a quick test. Create new test event, test one. And we will be, since it collects like a filter pattern, log group name, we'll just copy this. The test event helps us understand if anything is failing in our code. So here you can see we have given the parameters, filter group, log group name, as back, and we'll just save it. And then here we will invoke it. So let's see, execution started. Awesome. So let's see if we received any. So we are getting the messages here, already exists, boutique Postgres. So this means that the function is up and running. So we can close this and we can go back to functions. Now our fetch logs function is active. Next, we will be creating our AIOps fetch metrics function. Same, we will be picking the Python runtime. In our execution role, we will use another role here. This would be our Lambda role. And then we can go ahead and create function. This is a fetch metrics. Ignore because it's right now pulling the previous data. And now I am going to copy this code, just making sure this is 5.9. This is the latest Prometheus URL. Copy, paste, and then we deploy. So our function is successfully deployed. We'll do another test, create new test event, test one for this function as well. We don't have to follow a template, but we have some metrics we want to check if this function is able to invoke. So here we are giving the metric name as pod CPU utilization, what we wanted to query through Prometheus. This particular namespace, because for EKS, we need to use the container insights namespace. That's for the cluster. And then these are the dimensions. So let's just save it first. And then let's invoke it. Okay. So message group, body, no data. So we are getting status 200, which means at least it's doing the query correctly. The reason we do the invocation live is so that there are no permission errors. At times, a Lambda function cannot make the API calls. So this is very important to test it live. Now let's go back and deploy our third function, which is our fetch health function. So we will go fetch health. Again, Python 3.14. We will make sure you change the role because that has all the permissions to access the resources. So we have 5.9. That's the Prometheus endpoint and everything looks good. Now our functions are ready and they are deployed. The next step is to deploy the Bedrock agent, which is like the masterpiece in our entire workflow, because that agent is basically the model that would be doing the reasoning part. It would be calling these functions on the backend, fetching information, summarizing it. It will be giving the root cause analysis to the engineer. Before activating any service, we have to first fix the permissions. So in this case, we will be creating another role which will have custom trust policy. And since this is Bedrock, so we'll put this custom policy. We'll skip all these policies for now. Next, and then here we will be giving AIOps, Bedrock agent role. And then let's just go and create role. Just make sure the name is right, AIOps Bedrock's agent role. Now we will add the policies. Add permissions, create inline policies, add JSON. This would be our permissions. So what this particular role will be able to do is it would invoke the model, the selected model we have, and then it can also invoke the Lambda function. So Bedrock now has permissions to invoke the Lambda functions. Just how like Lambda has permissions to read resources like EKS resources, right? We gave the permissions previously. Same for Bedrock. We go next and we will just Bedrock permissions. You can just name it anything. Create policies and our agent role is ready. One thing you have to do is if you go to Bedrock, if you go here to model catalog, one thing you need to check is if you have access to the models. So for instance, if I want to use Claude Opus 4.7, I can write a prompt here. If it gives me this error, which means I don't have access to that model. So I have to enable it through Marketplace, or this particular model is just not accessible through my free tier. By default, there'll be a form like maybe I can show you right now. If I go to another region and I go model catalog, here I want to try Anthropic models. Let me just pick something like Claude Haiku. If I want to test it, it's available for me here. So because I've enabled it. Now if I go pick some other model, for instance, Claude Sonnet 4.6, if I do open in Playground. So in this case, I have submitted a form, which is why I'm able to access the models. We'll go to Amazon Bedrock and we'll be creating the agent. One of the things that you can explore here is that you have access to a bunch of models. That could be Anthropic Claude models, DeepSeek models, Google models. You can access all these models through AWS Bedrock. But a quick note here, if you are accessing Anthropic Claude model, for instance, so you have to fill a form if you're accessing it for the first time, where you have to give your company name, you can give your name, and then give a use case, something like create this agent. I've detailed the steps in the GitHub Repo as well, what description you can add for it for the use case. And it takes few minutes to get it approved. So you can use Claude models as well while deploying this agent. But for our case, I have used Quen model. So I can show you if I have access to the Quen model as well. So I'm using 32B model. If I do open in Playground, you can come here and you can check if your user has access to it. Look at this. It comes with a smiley. So this confirms that I can call this model through APIs. Now, we are not going to deploy the agent through the console, because when we do that, it becomes very complicated to make sure the OpenAI schemas are intact, and we have to do a couple of pre-checks as well, like checking if the roles are active. So what I've done is I've created an automated script, which you can also just run, and it will first do some checks, which we'll go through, and then it will deploy the agent with the system prompts. Before we dive in, I want to call out one platform you should definitely know. That is UptimeRobot. Now I know we already covered Prometheus and Grafana in our earlier video, and those are great for internal observability. That's basically what's happening inside your cluster. But here's the thing. If your cluster goes down, your Grafana dashboard goes down with it. So you need something watching from outside. That's where UptimeRobot comes in. And it is what most enterprise apps are leveraging today. It hits your endpoint from multiple global locations. So you catch outages the way your users experience them. No false positives, no blind spots. I've myself got it running across a bunch of my projects. API endpoints, model serving, webhooks, all in one dashboard. And the best part of this kind of work is they have their own MCP server. So you can wire monitoring straight into your agentic workflows. Exactly like the DevOps agent we are building today. Now what that means here is your agent can check your monitor status, create new monitors on the fly, pause alerts during deployments, or pull incident history, all as native tools. Same pattern as we are using the logs, metrics, and health status in this video. Just plug the MCP server like this in your agent workflow, and it will treat UptimeRobot as an action group. This is exactly the direction AIOps is moving. Agents just don't read dashboards now. They actually act on it. I would suggest you to definitely check it out and try their platform using my link. You can find it in the description below. So here's the script which is under the name deploy.sh. We start with giving it the right credentials, like this region, this is my identity. Basically, this is my account ID where this agent would be deployed. The role name, which we just created, and the name of the agent would be AIOps agent. So it will just print it when you run the script. Next, we will be doing some pre-flight checks. So this part verifies that all the required resources already exist. It checks if all the 3 functions are deployed. Then it also checks if the roles are created, because it is essential to make the API calls. And if anything is missing, the script stops early to avoid failures later. Then in this part, you are configuring the Lambda functions. Here in this part, what's happening is it's updating the function to make sure that Bedrock agent can invoke these functions. So this step basically allows the agent to actually use the three functions like logs, metrics, and the health check function. So this particular segment here allows the agent to actually use the logs and fetch the metrics and the health status as tools. So remember, the essence of having agents over models is that extra reasoning layer as well as the tool calling layer. Now, when you write a prompt, the agent takes a call, takes the decision, which function it needs to call and what metrics it needs to. So after this particular step is done, this is where the Bedrock agent gets created. Here we are feeding the agent with some capabilities. For instance, we are assigning it a name, and then we are assigning it some capabilities around like act like a senior site reliability engineer. This is how you need to think. This is how you need to understand the prompt. And these are the steps you need to take. In addition, we are also giving it instruction that cite the log entries. So don't just give a response, but also give the log entries from which you are giving that particular summary. This is the step 3, which is the most important one, where we define the action groups. So these action groups are basically where the agent gets its capabilities. So each action group is linked to a Lambda function. You can see the logs, you can see the metrics. These are the 3 Lambda functions. Now, one thing to note here is there's a thing called schema. This is an OpenAI schema. It basically defines how the agent talks to each tool. So if you want to go here and under schema, you can see under fetch logs. It defines what inputs the agent can send, like parameters, types, and required fields. It also defines what the response will look like, so the agent knows how to interpret the output. Without this schema, the agent wouldn't know how to call the Lambda function correctly or what to do about it when the response is generated by the Lambda function. So that is the main piece here when you're defining the action groups. You can have more functions as well, doing another API call to load balancer, for instance. So think of this segment as a contract between the agent and the tool. Now, this piece is basically the final step where the script prepares the agent, essentially compiles and activates it so it's ready. Once that's done, we can go back to the node and let's deploy this. Let's get into the CD projects, AIOps assistant. I'm going to just run the deploy script. And now here we can also, let's see. Yes, it's gonna just verify if it exists. Then it's running its pre-checks. Agent created. Okay. Now on the console, we can go here under agents. You can see it's under status preparing. Give it a few minutes. If you want, you can go here. You can see the name and you can see all the permissions. It is using the AIOps agent role. It's prepared. So we'll test it before we deploy the UI. Is the EKS cluster healthy? Is healthy. Here's the detailed response. All nodes are healthy. So it just summarized. The reason it is giving us a response in this format is because what we have defined here in our deploy script, we have given it a persona, how to understand the question, how to generate the response. This means our agent is working. One thing that I wanted to show you, that when you are setting up the model, this is where you set up your agent details. So if in case, for instance, I'm using the Quen32B model, you can deploy a Claude Sonnet or a Claude Opus model here as well. You just have to change the model ID and make sure you have access to it first. Whenever you are testing a newer agent with a different model, you go to Bedrock, you get into the model catalog, you open it in Playground, test it. If you're able to run the model, see the performance, if you like it, then you plug it in the script and then you can do the exact same thing. So this means our application is up and running, our agent is working. Are any pods down? Let's just do another check. And no pods are down. All pods in the boot namespace is active, which is correct because everything was working fine. But we will be triggering something that will break the system and we'll see how our agent responds. And now before we break anything, we will first deploy a fancy UI so that we can interact with our agent And we are using Streamlit UI. It is a simple web interface built using Streamlit. It's a Python framework. It lets you turn your backend logic like this AIOps agent into an interactive app. It helps you create those streaming input and output responses, right? So instead of calling the APIs directly, or exposing this agent as an API, what you can do is build this clean UI where you can add some input queries and see the results in real time. So for instance, if there's an on-call incident, the engineer can directly have that chat open and they can just ask the questions, and the agent will do all the work for them. So this entire Streamlit application was vibe coded, so pretty easy to do. You can customize it further, but I just wanted to show that you can build those interactive apps as like some portfolio project as well. You can show it live and you can maybe link it in your resume. So now we are going to run the UI, which is powered by Streamlit. So what we do there is, first step is to understand what this app does. So if you go to app.py, this is basically where we are importing the libraries. And before that, here's the requirements.txt. So this makes sure these libraries are installed. And then once that's done, we are fetching all the AWS credentials, making sure that's passed, and our UI app can connect to our agent that's deployed on AWS. So we will also pass the agent ID, which should match our ID here. This is a vibe coded app, so it gives you a customized version, something, your personalized chatbot. So how it's useful for engineers, for instance, there is an on-call incident at midnight. The engineers can come to this particular chat agent and then start interacting with the cluster, right, in natural language. So you can check around what were the errors, why did this server crash, all those things you can directly chat in natural language rather than running commands on the CLI. So this is the AIOps piece that I wanted to call out, that AIOps is you are adding intelligence to the normal operations workflow. So with DevOps, you added automation, and now with AIOps, you're adding this model level intelligence onto that automation. You see, you're leveling up. So this is a very cool use case. So let's deploy it. So I have made sure that all my access keys and IDs are up and running. We'll run pip install so that we make sure all the libraries are loaded, already installed. And then we go and run. I was already running, so let's just run the app. It's going to restart my Streamlit application. So now it's running. Let's just copy this and maybe we'll run it here. Woohoo, look at this. So you can see this is online. This is your AIOps assistant. Hi, let's see if it's interacting. Okay, it's ready. Is my cluster active? Your cluster EKS is active because that's what my agent is reading. It is configured to read everything from that particular EKS cluster in that particular namespace. How many services are running? Okay, so it tells us accurately that there are these 7 services that we deployed when we were building our boutique application. Now let's do something. We are going to break this and we are going to see if our agent is picking that up or not. So before anything, let me make sure my Argo CD is, let me go to my microservices and we go into my GitOps and we go to Argo CD YAML. So you see the Argo CD sync policy here is automated. So if I delete anything, it's going to pick it up. So I'm going to just comment this and then I'm going to keep an empty sync policy, which means this is what, and this is my namespace. So I'm going to just do kubectl apply -f argo cd argo YAML, and it's going to obviously find where it's located. It's configured. So now anything I change, it's not going to automatically sync and force the fix, because Argo CD's work is to fix the deployment, fix the drifts. So I'm going to delete a pod, or I'm going to maybe delete or scale down a service. Let me just get the deployments first. Control O. So I'm going to scale the order. So I'm going to kubectl scale deployment orders -- replicas equal to 0. Yes, don't ask me again. So now we have 0 order pods running is the cluster active? Are they down in the application? So since we scaled down our orders deployment, the agent can quickly pick that yes, it's down because it's been scaled to 0 replicas. There's no running pods. Let's do yes. So you can see it based on your findings so far, the orders deployment is scaled to 0 replicas. So it's something manually done. And it gives you the root cause, it gives you the summary of evidence, immediate fix, and also the prevention steps. So this is how you can build your agent. Now let's delete a service. Yes, order service. Okay. Are there any services down? So we are triggering things. Let's see if it's pulling that. Okay, so it can pull the orders service, which is down. So you can see all the other services are healthy and it can give you some next steps as well. So this is basically our AIOps agent. That's a wrap. We did a bunch of things in part 4. Used an existing boutique application deployed on EKS, set up the whole logging part with Fluent bit, exported logs to CloudWatch, configured all the permissions for CloudWatch, Lambda, and EKS node groups, created the Lambda functions, and configured our Bedrock agent to work with these services. Eventually, we deployed the Streamlit UI and could finally see things in action. So in summary, we went through the whole system design concepts, looked into the detailed workflows, implemented those DevOps workflows, added the AI layer, and practiced AIOps. This is basically a full-grade DevOps platform. Why? Because we are using the latest tools and technologies. We are implementing the right system design concepts and actually practicing how real-world applications work. So make sure you document every part of your journey here. The reason here is when you are writing or even documenting it with your AI chatbot, that's where you'll be able to connect the components here. It can be overwhelming, but hey, you have to upskill now in order to be job ready. So I wish you all the luck and I seriously hope this helped. All the code, concepts, workflows are in the GitHub Repo linked below, and you're building this and documenting it in any of the social media platforms. Make sure you add the tag DevOps in action. This will really help me track it. If you have any changes or comments for the GitHub Repo link, please create issues and I'd love to have some contributors there. And any questions, drop it in the comments below. Thanks for watching and see you in the next video.